Good morning to all. In today's session, we will see about the construction and working principle of moving iron instruments. We already know that in a permanent magnet moving coil, that is PMMC instrument, the magnet is a permanent magnet and the coil which is wound on a former is going to move proportional to the value of the measurand. In a moving iron instrument, the iron is in the form of a thin aluminum disc and we have the coils to be fixed. In moving iron instrument we have two types. One is the moving iron attraction type of instruments and the other one is the moving iron repulsion type of instruments. Here the basic principle is we have a moving coil, a moving iron, which is this, and we have a coil which is fixed. So whenever we want to measure a parameter, the moving iron is either attracted towards the fixed coil or it is repelled away from the fixed coil depending on the force of attraction, either it is attraction or repulsion. So basic construction is it comprises of flat coil and a narrow slot like opening. Moving iron is a flat disc and eccentrically mounted. So when current flows through the coil, magnetic field is produced which attracts moving iron towards it. So because of that, the pointer is going to move. The controlling torque is produced by two springs. The friction we have already seen. The type of friction employed is air friction damping because we have a chamber and we have a piston, and this piston is attached to the moving system, which is the moving iron, which is in turn connected to the spindle. We have a better view of the moving iron repulsion type of instrument in this. So we have two vanes. One is the movable vane and the other one is the fixed vane. So depending upon the supply or the value of the measurand, this movable vane is going to repel away from the fixed vane by the force of repulsion. And here in this coaxial vane repulsion type of instruments, we can see that the moving vane and the fixed vane are coaxially placed. So depending on the value of the measurand, there will be a force of repulsion which is going to make the pointer move. So which is in turn connected to the spindle. We can see the spindle also attached here. So this spindle in turn will be connected to the pointer. So advantages and disadvantages of moving iron instruments. The same instrument can be universally used for both AC as well as DC, which is one of the main advantages here. Torque versus weight ratio is very high and error due to friction is less. The instruments are cheap, of course. Instruments have high accuracy with 20 to 40 degree circular scale. Disadvantages is the scale of the MI instrument is not uniform and accurate readings are not possible because it depends on the instantaneous value of the current. So here also we have posted some quiz questions which are expected to complete by November 15th and uploaded. And thank you for your patient listening. Thank you so much.